Hello everyone. In this video, I'm going to talk about relations among angles, arcs, and chords in the circle. In the figure, if x is equal to y, that means the angle of the point AB and CD pointing to the center are equal, then we have two other things equal. Based on the arc length formula, theta over 360 degrees times 2 pi r. Since 2 pi r and 360 are fixed, and if the angle theta are the same, then we have the same arc length. So we will have the result, the arc length of AB is the same as the arc length of CD. And whenever you want to use the result, we will quote the reference equal angles, equal arcs. And since these two angles are equal, together with the radii, we can conclude that triangle OAB is congruent to triangle OCD. Then we will have AB, the chord length AB and CD are equal based on the corresponding sides congruent triangles. And if you want to use this, you need to quote the reference equal angles, equal chords. Now on the other way round, if the condition given to you is not the two angles being equal, but the arc length, maybe the length of the chord are equal, then we will have similar results, but just different references. Say for an example, the same setting, if we instead have the arc length being the same, then based on the arc length formula, we will have the angle of the sector equal. And also, since the angles are then equal, we have congruent triangles to say that AB is the same as the length CD. So if you want to have these two results found based on the given arc length, you need to quote the reference equal arcs, equal angles, or equal arcs, equal chords. And finally, if instead the chord given are the same, then based on congruent triangles, you should have the angle of the triangles being equal. So we have x equals y, and since x is equal to y, we can have the arc length AB and CD are equal. So if you want to use these two results, you need to quote the reference equal chords, equal angles, equal chords, equal arcs. And now, when we are talking about something equal, then what about something is not too equal, but they are in proportion? Now, I'm going to talk about the proportional relations between arc and angles. And you should figure out that, oh, why chord is missing, right? And I will explain to you later why chord is not in the relation about proportion. Now, in the figure, we have two sectors, one of arc length L1, one with L2, and the angle of sectors are theta 1 and theta 2 respectively. And in the figure, we have one relation that based on the arc length formula. If I consider the ratio of the arc length L1 over L2, and then each can be found by theta 1 over 360 degrees times 2 pi r, and theta 2 over 360 degrees times 2 pi r again, because they have the same radii. And by then, you should know that the arc length ratio is the same as the angle ratio at the center. And thus, in the figure, we should have L1 over L2 is theta 1 over theta 2. And it can be written in the other way around, that if theta 1 over theta 2 is equal to L1 over L2. Okay? If you want to use this reference, you need to quote it arc proportional to angles at center. Arcs proportional to angles at center. Now, when we talk about angles at center, what about the angles at the circumference? They are of a relation. The angle at center is twice the angle at circumference, right? So, in order to save time, we have a new reference assigned to angles at circumference. So we just reduce the size of theta 1 and theta 2 by half to get the value of xy, right? And we should have the similar result, that the arc length ratio L1 over L2 is 2x and 2y, and hence x to y, right? And so if you want to use this based on the arc length, you want to claim the angles are of the same ratio, you need to quote the reference arc proportional to angles at the circumference. Or in the other way around, if the two angles are given to you and you want to quote about the ratio of the arc length, then you need to quote the same reference again. Okay? Now, 2 points to note. Number 1, why chords are missing about proportion. Okay, just a counter example to you. If I have two sectors, one with angle x and one is angle 2x, and from the above we should have the arc length. If one arc length is L, then the other thing is 2L, right? And if I dissect this angle 2x, the sector with the angle 2x, into two smaller sectors with angle x, then each of these sectors should have the arc length L, isn't it? And based on the angle, equal angles, equal chord, equal arcs, equal chord, etc., we should have the three portions here. 1, 2, and 3. Okay, the length of these three parts or three chords should be the same, right? But if we consider back on the original sector with angle 2x, the chord length of this sector should be this one. And if I assign it as, say, D, and we can see obviously that D is not equal to L plus L. Okay, so the proportional relations does not apply to chords. Okay, it only applies to arcs and angles. Okay, this is one thing to note about chord. And second, you may also think of whether we have the chord relation or angle relations with the angle at circumference. And yes, we have this kind of thing. We should have something equal arc lengths, then we should have the equal angles at the circumference. And if we have the equal chords and they have the equal angles at center, and they should have the equal angle at the circumference, right? And so you can add these two reference to this page. That means if you have equal arcs, you have equal angles at center, and also you should have the equal angle at the circumference. Okay, so you can add the same thing, equal arcs, equal angles at the circumference. Okay, so for equal thing, you can create your own reference based on the need. Okay, whether it's at center or at the circumference. Okay, you do not need to point out if it's applied to the angle at center. Okay, but rather if it's about angle at the circumference, you need to say it. Okay, so in here we have if the angle at the circumference are equal, then you have the arc length equal, we should have equal angles at the circumference, equal arcs, something like that. Okay, so I would just write one in each type. Okay, and lastly, equal chords are equal angle at the circumference. Okay, so that's all for this video about the relation among angles, arcs, and chords, about something equal and something about proportional relation. Okay, and in next video I will give you some work examples based on the use of these references. Okay, stay tuned and thanks for watching.